We're looking at 26 from the MAC 1140 Pre-Calculus Final Exam Review. 26 states the number of bacteria in a culture can be modeled by the function p of t is equal to 250 multiplied by e raised to the power of 0.075 t, where t is in hours. So let's go ahead and start working on A. A is asking how many bacteria went in the culture initially. So we know that our initial time is when t is equal to 0 hours. So we can go ahead and plug in 0 for t. So t is equal to 0, and we have our original function p of t is equal to 250 e times 0.075 raised to the power of t. So when we plug that in, p of 0, 250 e 0.075 times 0, we get p of 0 is equal to 250 e to the power of 0, which any number raised to the power of 0 is 1. So this will become 250 times 1, which gives us that there were initially 250 bacteria. Now, for part B, it states how many bacteria were in the culture after 12 hours. So now instead of t equals 0, t is equal to 12 hours. So we're going to follow the same steps and plug in 12 for t. So when we do that, we get 0.075 times 12. When that is reduced, we get 250e raised to the power of 0.9. And when you plug e raised to the power of 0.9 to your calculator, you get 250 times approximately 2.46. When you completely solve that, you get that there is approximately 614.9 bacteria after 12 hours. Now, looking at part C, it's asking when will the population reach 4,000 bacteria? And it's asking to round our answer to 2 decimal places. So we know that our final is going to be 4,000. So instead of plugging anything in for t, we're actually plugging it in for the first part of our function, which is this segment. So when we do that, we're going to get 4,000 is equal to 250e raised to the power of 0.75 t, and t is what we're solving for. So to do this, what we have to do is divide both sides by 250 to free up that e. And when we do that, it reduces down to 16 is equal to e raised to the power of 0.075 t. Now to further simplify, we need to use our logarithmic rules or our natural log rules. So I'm going to take the natural log of both sides. And one of our properties of logarithms is the power property, which is we can take any exponent and bring that down in front of the logarithm. So let's go ahead and do that. We'll get the ln of 16 is equal to 0.075 t times the natural log of e. And we know that the actual natural log can be is written as this. That's the natural base of it. So when you have the natural log of e with the argument of e, this reduces down and cancels out to the exponent of 1. So that's what we have here. So we're just left with that canceled out, and then we continue on. So we get the ln of 16 is equal to 0.075 t. Now to finish it by isolating t, we divide both sides by 0.75, so 0.075 again. And now we have t is equal to approximately 36.97 hours. And these are your final answers for part A, B, and C.